But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills, because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
Okay, engine stop. Listen, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
That's one small step for man, one giant leap for mankind.
Hi, I'm Steve Purcell and it's 2019. That means it's been 50 years since Neil Armstrong spoke the words, "It's one small step for man, one giant leap for mankind." And in this video, we're going to discuss that. First and foremost, I'd like to clarify, I was born before Neil Armstrong spoke those words, so as a child I grew up in the space race and it was fantastic. One of my favourite television programmes was something called Space 1999. It's where we had a base on the moon and people lived and worked there, and I thought it was amazing. As a child, that was something I dreamt of, to live or work on the moon. It was something I really wanted to do, and 50 years later there's no sign of that ever happening. And that surprises me because 50 years ago, that was the way we was going to go. We would have bases on the moon where people would live, work, or even just take a trip there. And it's something I would love to have done. So don't get me wrong, I'm really disappointed that I don't believe we landed on the moon. It's something I believed in as a child, but the evidence doesn't point to that. A quick Google search or a YouTube search and you'll come across hundreds and thousands of articles and videos regarding the lunar landings of the 60s and 70s and man stepping foot on the moon. And there's loads of evidence to say that it happened, loads of evidence to say that it didn't happen, and people trying to disprove one thing and prove another thing. I won't go into that in this video. There's three things that stand out in my mind. There's one question that I've not seen asked anywhere else, and I've certainly not come across an answer, and we'll get to that later in the video. But there's also a couple of scientific things that make more sense to me. Now, we've all seen the photographs, the evidence of crosshairs being in front of and behind astronauts and things on the moon, which doesn't make sense. We've all seen the things regarding the shadows on the moon's surface going one way and another way, which can't really happen in natural light. If it was natural light, they would all go in one direction. All the shadows would point the same way. That can only happen in natural light. If there's artificial light involved, shadows can go in numerous directions. So it looks as though artificial light has been used in the moon photographs. But I don't find that as hard evidence because there may have been some lighting on the lunar module that could cause these shadows going in different directions. It's not hard, fast evidence. There's also things like props. There's a rock with a letter C on it and then a corresponding letter C on the ground in front of it. And this is a Hollywood technique. It's what stage designers do, so they know where to put the props when they're making films. So it does look as though a lunar set was used. We have things like the Kubrick horizontal, where you've got a stage set and then a projection behind it to make it look more of a world or something like that. But these can all be proved and disproved. It's not hard evidence. As I say, I have one question to ask. And there's also a couple of scientific things that don't make any sense to me. So let's have a look at what I think is hard evidence. First off, we'll talk about the Van Allen belt. And if you're not familiar with what that is, it's basically a belt of radiation that goes around the Earth's surface. In fact, there's two of them. It's kind of a donut shape and it starts around 400 miles above the Earth's atmosphere. Now, in 1969, we sent 3 astronauts through this radiation belt. They went to the moon and then they came back with no signs of radiation poisoning. 50 years later, NASA scientists are saying we need to solve the Van Allen belt before we can send people into deep space.
We are headed 3,600 miles above Earth, 15 times higher from the planet than the International Space Station. As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. We must solve these challenges before we send people through this region of space. We must solve these challenges before we send people through this region of space. We must solve these challenges before we send people through this region of space.
So we can't get through the Van Allen belt with humans today, but we could do 50 years ago. That just doesn't make any sense. It's scientific evidence that we haven't passed through the Van Allen belt. How did we do it 50 years ago? The second thing is regarding the Lunar Rover module. And this is a vehicle that was on the lunar surface and the astronauts used it to travel around the moon. And these was battery-powered vehicles. It was powered by lithium-ion batteries. And as we all know, these batteries are quite temperamental. They have certain operating temperatures. So let's have a look in the Lunar Rover Module Operations Handbook. The Lunar Rover Vehicle Battery. Maximum operating temperature 125 degrees Fahrenheit. Survival upper temperature 140 degrees Fahrenheit. Minimum operating temperature 40 degrees Fahrenheit. Minimum survival temperature minus 15 degrees Fahrenheit. What is the temperature on the moon? Well, the average temperature on the moon at the equator and mid-latitudes varies from minus 298 degrees Fahrenheit, that's minus 183 degrees Celsius at night, to 224 degrees Fahrenheit, that's 106 degrees Celsius during the day, because the moon has no significant atmosphere to block some of the sun's rays or to help trap heat at night. Its temperature varies greatly between day and night. So why would NASA put these batteries on this lunar rover module that aren't going to operate on the lunar surface? They would operate on a Hollywood set, but not on the lunar surface. That's scientific evidence, part 2. We didn't land on the moon. And let's touch on the lunar module. Have you seen it? Have you seen the images of it? It looks like a child's put it together. It's made out of tin foil and sticky tape. It's not something that a NASA engineer would put together. It just looks really, really poorly made. Would you go to space in something made out of tin foil and tape? I know I wouldn't. I wouldn't even sit in the garden when it rained in it because the chances are I'd get wet. And the reason given was the cost. It was too expensive to send people to the moon. Yet today, the US government and NASA are spending $70.7 million per astronaut for a seat on a Russian Soyuz rocket to go to the International Space Station. This doesn't make any sense whatsoever. Surely you would be spending that money on your own space program to still send people to the moon, because that's a new frontier. If you could take control of sending people to the moon, surely that makes more economical sense than spending £70.7 million per seat on a rocket to your basically superpower enemy, Russia. Why are you doing that? Well, now it's time for my burning question. And it's a question that's not been asked anywhere else, not that I can find, and I certainly can't find an answer for it. And it's to do with navigation. You see, the Apollo craft relied on inertia navigation, something that was developed in the 30s. And this wasn't really very precise. It was good on land because it had point A and point B and could navigate to it. But in the solar system, the Earth is rotating around the sun and the moon is rotating around the Earth. So that causes problems. Point A and point B are constantly moving. So this navigation system required a sextant for alterations to the course. And this was using stars. So we're going to watch a couple of clips. The first clip is regarding the navigation system and the sextant.
Each day, a little bit of error creeps in.
In long missions like Apollo 8, the inertial measurement unit isn't quite constant. It does drift a little bit.
So the second part of the system is a check on the inertial unit, a way to correct its daily error, the Apollo Space Sextant.
After about a day, you want to have somebody go to the sextant in the wall of the spacecraft, sight on a couple of stars, and then basically correct the orientation.
With the Space Sextant, the navigator can determine the spacecraft's location by measuring the angle between a reference star and the edge of the Earth. Knowing that angle, he can use trigonometry to calculate his position in space. Together, the inertial measurement unit and space sextant, combined with ground tracking, will tell astronauts and mission control where they are.
And now for the second clip of the 3 astronauts on Apollo 11.
I don't recall during the period of time that we were photographing the sonar curler what stars we could see.
I don't remember seeing any.
That's not sight.
I don't remember seeing any.
Neil, you were.
I don't remember seeing any.
Neil, you were.
I don't remember seeing any.
So my question is, if you relied on the stars for navigation to the moon, how did you get there? Because you couldn't see any stars. Well, there's plenty of evidence for everybody to have a look at and make their own minds up on whether we stepped foot on the moon in 1969 or whether we didn't. It's one of those things where everybody loses if it didn't happen. It's just unbelievable. I would hate this to be something that didn't really happen. It would really ruin my childhood. So I hope I'm wrong, but the evidence I've looked at doesn't make it look as though I'm wrong. We didn't land on the moon in 1969, and I'm devastated about that. Well, thank you for watching the video. If you've enjoyed it, please smash that like button with a thumbs up. I would really appreciate it. On this channel, we're all about photography, cinematography, drones, tech, news, views, reviews, tips, tricks and tutorials, the occasional conspiracy theory. So if you like that kind of content, please consider subscribing to the channel. Hit that notification bell and you'll know when I upload new content. And hopefully I'll see you again very soon.
Okay, engine stop. Listen, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.